Hello dear friends, this is Sonigra and today in the subject of mechanical drafting we are going to discuss the chapter titled as projections and sections of solids. The today's discussion covers the objectives. The first objective is to draw various views based on a given condition, to understand various positions of cutting plane, and to draw front view, top view, side view and true shape of the sections as per the given position of the solid. And we will cover four basic solids, that is cone, prism, pyramid and cylinder. The example number 1. A triangular prism of edge of the base 40 mm and axis length 80 mm rests on one of its rectangular faces on the ground with the axis inclined at 30 degree to VP and parallel to horizontal plane. It is cut by a cutting plane perpendicular to vertical plane, inclined at 30 degree to HP and passing through a point on the axis 10 mm from end surface nearer to the observer. Draw front view and sectional top view. Here triangular prism is given, and as we know this is the triangular prism. It is having two triangular faces and three rectangular faces. Here it is given that this solid is resting on one of its rectangular face. So it would be like this. This is resting on one of its rectangular face, and this is the case when it is given that it is resting on triangular face. So here the first step, we will assume that it is resting on its triangular face. Then we will tilt this front view like this, and after tilting this solid on its rectangular face, this one, we will draw its top view. Then that top view would be like this, and after that we have to tilt this top view such that its axis makes an angle of 30 degree with XY line. So how to draw this? This is the brief data. A prism, triangular prism, side length 40 mm, height 80 mm. It is resting on rectangular face on horizontal plane. The axis 30 degree to VP and cutting plane makes an angle of 30 degree to HP and on the axis at a distance of 10 mm from one of its triangular face. So as it is given that it is resting on its rectangular face, first we have to draw its top view like this. In top view it would appear as a triangle, and the top view should be drawn in such a way that one of the side, this side, makes an angle of 90 degree with this reference line XY line, and according to this top view the front view would be like this. So for this triangular prism, top view is a triangle, front view is a rectangle, and it is given that it rests on its rectangular face. So let me assume this rests on this face. So tilt this like this. So now this face is on XY line, and accordingly this will be top view. If you look from top, this edge would be visible, which is represented by this line. This line shows this upper cutting edge, upper edge. Now let me draw this problem on our drawing sheet. These are the two steps which we have drawn. Now in third step we have to tilt this top view in such a way that it makes an angle of 30 degree with XY line. So let me draw this problem. First we have to draw its top view. It would be like this. And second, we assume that this face makes an angle of 90 degree with XY line. Hence this face, name it as say A, B and C, and accordingly A dash, B dash and C dash points would be there. Now tilt this rectangle in such a way that this rectangular face on XY line. Hence here 2 points would be there, A dash, B dash, here would be point number C dash, and redraw this rectangle by drawing arcs or by measuring dimensions of respective points in such a way that one line is on XY line like this. So now this edge, A dash B dash edge is on XY line, and C dash point would be here. And locate its center of gravity. So for that we know the procedure. Join the end point of triangle with the midpoint of opposite side like this. Join A with the midpoint of BC, join C with the midpoint of AB, and intersectional point is the axis, and from this point draw, from this point, this is the apex point, and from that point draw its axis like this, one long dash, one small dash. And as it's a solid prism, here no any line would be there. Similarly, we can transfer this center line by measuring the distance to this front view as well, like this. Right? Now draw its top view. So for that, let me take projections from each end. Projection from this C dash, A dash and B dash, that is vertical line from A dash, B dash and C dash, and horizontal line from A. So here is one point, horizontal line from point B like this, and horizontal line from point C. So that would be like this. So we have located 3 points, A, B and C. A point would be here, B point here, C point would be there, and B point would be here. A1, B1 and C1. Similarly, here also we can draw projection line and draw and locate 3 points accordingly. So this is the top view. Join all these points with the straight line. And this is the top view of given solid if it is resting on its rectangular face. Right. Now it is given that this axis, so let me draw the axis here also. So here axis would be somewhere here, it will be hidden. This axis makes an angle of 30 degree with vertical plane. So redraw this top view in such a way that its axis makes an angle of 30 degree with XY line. So first we draw line at an angle of 30 degree with XY line and transfer all the points by measuring the distance from the previous top view, and just redraw all these points over here. So this rectangle is redrawn like this, and this angle or angle of this axis with XY line is 30 degree. So let me draw axis here as well, right? And this angle is 30 degree. If we draw here a reference line like this angle is given in the data, that is 30 degree. Now name the endpoints or rename. A1, C1 and B1 are here. Now this is the top view. Find out here appropriate front view. So for that again we will take the projections, vertical line from point A1, vertical line from point C1 and vertical line from point B1, and appropriately accordingly horizontal lines from respective points C dash, A dash and B dash. So the points, 3 points would be here. Here is point C dash, or we can name it as a C1 dash. Here would be A1 dash and here would be B1 dash. Means vertical line from point A1, horizontal line from point A dash. Here is point A1 dash, B1 dash and C1 dash. Similarly, from these points, these 3 points also we can project the points, vertical lines from all these points and horizontal lines from front view like this, and we can locate 3 points over here also. Now as we are looking from here, this is the front view for this top view. This edge would be fully visible, and this edge will not be fully visible. A point would be hidden. So all these points from this edge should be drawn or should be joined with the full line like this. They are joined with the full line as it's fully visible. And here A is not visible, so that is joined with the dotted line like this, as it's a hidden edge. This is outside line, C1 B1 dash, so represented by full line. This is also full line, and this edge is also a full line. So this is the front view for the third position. Now we have to draw its cutting plane. Here in data it is given that the cutting plane makes an angle of 30 degree with XY line with horizontal plane, and for front view it's with XY line and passing through a point at a distance of 10 mm from the axis. So here on the axis this represents the true length. So on the axis at a distance of 10 mm mark a point, and from that point draw a vertical line like this, right? You should not directly take distance 10 mm from here. You measure the distance 10 mm from top view like this. Let me insert the dimension over here for clarity, because it's a top view, and a top view is here, true length is there. So this distance should be 10 mm. Here students may do mistake that they measure distance from here in front view. No, it should be taken from this top view over here, from one of the surface. So this distance is 10 mm. From this point on the axis draw straight vertical line and locate the point on this axis. Here the axis of the solid is there, so transfer that project that axis from the side view from previous front view, and this is the axis, and on this axis here is the point through which a cutting plane will pass. So from this point draw a cutting plane in such a way that it makes an angle of 30 degree with XY line. So this is the cutting plane which makes an angle of 30 degree with XY line, right? And this is the retained portion. So arrows should be drawn like this. One arrow is here, one arrow is here, because this portion is retained. So this upper one is removed portion. Now you can light this portion or erase that one, and let me draw its a sectional top view. So for that, find out the points of intersection between cutting plane and the edges. You can see here, this is the cutting plane and this is the edge, C1 dash edge. So intersectional point is somewhere here. So let me name this point as point number 3. It is somewhere here. Similarly, it cuts this edge at this point and this edge at this point. So this is point number 1 and this is say point number 2. So 3 points are there in the front view, and transfer all these 3 points to its top view by taking projections from respective points. Vertical line from point 3. 3 point is on C1 dash. You can extend the name. It's a 3 dash because it's a front view. So 3 dash, 2 dash and 1 dash. So here point number 3 would be there. 3 dash is on C dash generator. So 3 point would be on C1 generator. Vertical line from point number 2 dash and 1 dash would be here. From 1 dash point is here. From vertical line from point 2 dash the point would be here. So locate both the points. Point number 1 is here. It's a point number 1, and point number 2 is here. Point number 2. Now join all these 3 points 1, 2, 3 with the straight lines like this. So this straight line represents the cutting portion, and here internal portion should be removed, and we should draw section lines in this region, in this 1, 2, 3 triangle. So this section line represents the cutting portion of this triangular prism like this. So this is the sectional top view and this is the front view. You can name the views. It's a front view and it's a sectional top view, right? Here true shape is not asked, but you can draw the true shape with the similar method which we drawn earlier by drawing the lines, vertical lines from respective points 1, 2 and 3 like this. You can draw vertical line from lines from 1, 2, 3 which are perpendicular to that cutting plane line, perpendicular to this line. Measure the distances of point number 1, 2 and 3 from this top view and locate appropriate points, and its true shape would be like this. As here, if you measure the distance of point number 2 from XY line, this is the distance, point number 2 to XY line, and here point number 2 to XY line would be like this. So mark here a point, point number 2 over here, point number 1. So measure the distance of point number 1 from xy line, this distance 1 to xy line, transfer that point over here. So point number 1 would be here, point number 3 is here. So xy line to point number 3, measure this distance from 3 days, draw an arc. Here is point number 3. So name all these points. Here is point number 3, here is point number 2, and here is point number 1. And join these 3 points with a straight line, as it's a solid having all straight edges, and cutting plane is also straight line. So this is the true shape of the section, and draw section lines in this true shape which makes an angle of 90 degree with this cutting plane, not xy line. You can name here, it's a true shape, right? So we have drawn all 3 views. So these are the steps. Step number 1, 2, 3, and this is final step, step number 4. I hope the solution of this problem is clear to you. Now let me draw second problem. The data for second problem: a pentagonal prism of edge of the base 30 mm and length of the axis 80 mm rests on one of its rectangular faces with its axis inclined at 30 degree with VP. It is cut by a vertical section plane inclined at 30 degree to VP and bisecting the axis. Draw sectional top view and a front view of the prism. So here pentagonal prism is given. You can see here, this is the pentagonal prism. Let me see this pentagonal prism. It's opening. In pentagonal prism, it is having 2 pentagonal faces and 1 rectangular face, this one. This is pentagonal prism, you can see here. And here, this pentagonal